So, hello everyone. I hope you can all hear me well.
Stop.
So, let's get started for my session. I think I have only 20 minutes. So, before I start, I would like quickly to introduce myself to all of you. My name is Dominic Duing, and I'm working as a technical marketing specialist for Chemours, and I'm supporting the introduction and implementation of A2L refrigerants. Today's topic will be around the refrigerant 454C, and I will give you an outlook about the wide range of possible usages of 454C. And let's not waste too much time. This is the agenda for today. I will very quickly show you or give you a small introduction into the topic of regulatory, very briefly about the F-gas regulation, about some, GWP limitations since March this year. So we have the new regulation. Next will be an introduction or an overview about low GWP solutions dedicated to the limits of the or placed into the F-gas regulation, and then I'll have some technical comparison based on some ref drop calculations, and then we'll show you some real life case studies, implementation of systems into different applications and in different sectors. Then we'll have a small conclusion and an outlook about further efficiency or higher efficiency of the refrigerant 454C and how we as Chemours can support you in achieving that.
See you later.
So I don't want to go too much into details here. I think all of us will know or roughly know the path of the last, let's say, 50 years. So currently we're in 2024 in March. The new F-gas regulation came into place, and with that we have new limitations and considerable bans for some refrigerants. And here's the, let's say, broad overview. So for different sectors, starting with air conditioning and heat pump, there's the GWP limits, which you see on top of it. So we have 150 GWP limit for air conditioning and heat pump applications above 12 kilowatt. And here you can see that 454C suits in there, how I will show you later. Next point is commercial refrigeration, so refrigeration applications. Also here we see a GWP limit of 150. And there's another one for dedicated to chillers above 12 kilowatt. There we're talking about 750 GWP limit. And there's our solution from Chemours, R-454B. But as already mentioned, today I will focus my presentation on R-454C, dedicated to AC heat pump and also into refrigeration applications. So, considering the GWP limitations, I've made a small overview of refrigerants which have been used very often in the industry, even though into different fields of especially commercial refrigeration in that case. So we have on top, we have 454C. It's an A2L refrigerant. So we have propane as an A3, so a hydrocarbon, and we have CO2, R742. Very important here that case. So the pointer doesn't work anyway. So the potential for recovery. So it's a big topic also for us, for Chemours, with the F-gas regulation, quota drops, etc., and also the whole circularity of equipment, refrigerant, etc., supplying the value chain. Very important, the potential for recovery for all F-gas especially. So considering also other refrigerants such as 449, 513A, whatever. So it's a very important topic, and refrigerants, maybe small shout out. So the should be recovered, recycled, reclaimed, and brought back into the system again, and that we are having like a circular economy at this point, supporting the whole value chain. Further right, you just see some technical comparison, a little bit like practical limitation, which is obviously valid for flammable refrigerants, so in that case, R-454C and propane in this case, and some further technical information here to show. Next, some characteristics, and this is a very important topic nowadays if we consider the PED fluid group. So there's a difference in A1, so for A1, A2L, and A3, and there's the PED fluid group. Considering this, building a system, it is important that the component classification itself, but as well as the system classification in the end. For that, we need to make sure we have the right components used into the system, using A2L refrigerants in that case, and making sure we have all the certifications for the components and also for the complete system in there. Mentioned it already, so the component classification itself is also in accordance with the PED fluid group, and a little different for the service equipment while using an A1 refrigerant. So the service equipment, I mean, as all we know, then we have the A2L. The mechanical tools are exactly the same. We just need to look a little bit to the electrical equipment, especially the service equipment, considering again, like different PED fluid grade, flammable refrigerant, so we need to take care of that. Same as propane, there are also in some cases you need anti-static tools to make sure you're on the safe side when handling those tools and the refrigerant. And another very important part, which comes more and more often into discussion when I talk to customers, many people are afraid of the part of the risk analysis, even though this is mandatory for many years according to the machine directive. Doesn't matter which refrigerant I'm using. If I build a refrigeration system, we have to do risk analysis. That's a very important point. And if you need support, if you have questions, I'm happy to support. Please reach out to me, and we'll happy to support you. So the next point would be, just call it their temperatures, but it's a very valid point. Not yet in Europe, even though OEMs can already use it. But the point of the auto ignition temperatures for A3 refrigerant, but there is a possibility to classify products according to regulations using the HSIT, which is the hot surface ignition temperature, valid for A2L refrigerants, especially in the ISC 2-40 in the latest edition for heat pumps, for example. This can be used for component or for system certification, and this gives you additional input and support in classifying the product, which easify the whole process in the end. Some more things like minimum ignition temperature. So what we see is that the energy which is needed to ignite the refrigerant. Just wanted to show you that there is very often heard it's flammable. Yes, it's both kind of flammable, but it's very different. Just to let you know. And next point will be ATEX zones, because also when talking to customers, very often I hear or I get the feedback, well, I have a flammable refrigerant. What about ATEX? Do I always need ATEX? Do I need to introduce ATEX zones everywhere? Well, depends, obviously. So it's also, this is very different. You have zones from, according to ATEX, from 0, 1, and 2. And for A2Ls, your maximum in zone 2, which means that there's usually no or if when in a very short period only, like a flammable atmosphere, which also helps for the overall classification. Considering the refrigerants, flammability, pressures, etc. So we have different regulations in Europe, but all over the world as well, of course. So, for example, in Europe we have the EN378, but like kind of the counterpart on international level is the ISO 5149, and we have the 2-89 for example, cabinets, and the 2-40 for heat pumps. I already mentioned it, but the risk from the refrigerant itself, so there is the risk, and it has to be considered, and no matter what the refrigerant is, we have to make a risk assessment, so which is a part of the risk analysis. So the first step is, so we have to analyze the risk from the overall system, and then we have to evaluate the risk, and this overall it's called the risk assessment. And obviously safety. So we have different kind of refrigerants. We have now also with A2Ls, we have the flammability. Is it an issue? Well, also this depends. So there are things we can do for it. We can support customers. There are, say, in the regulations, we find the right way of doing it. They're going to guide us through what we're going to have to do to make the system, but also the surroundings, so the whole area where the system is installed, to make all of that safe. So, for example, in EN378, you want to find some information about gas detectors, which ones to install, consideration, and where to install them, for example. With safety shut-off valves or ventilation system could be, or like power supply, and obviously like personal equipment, which also being used. Next part is the different refrigerants. So we have A2L refrigerants, which are not new to the market, especially R-153C or R-32, very much used in the air conditioning industry. So A1 and A2L from the system structure as well as thermodynamics are very, very similar. So the system itself, the system structure and the around is very similar. So there's no currently not used, like it's very easy fight system compared to other solutions. If we consider then, for example, R290 secondary loop, this is also a system which is used very often in some supermarkets, but here we have to obviously cope with the higher flammability, and there's been used, for example, 150 or 500 gram, depending on manufacturers, but there's very often used also a secondary loop in order to make sure we're on the safe side. As well as with CO2 in this case. So we've just seen a from presentation from Carrier. So there are solutions using CO2, obviously, especially in commercial refrigeration or in bigger applications. But everything has its ups and downsides. Obviously, here we need to make sure that in order to cope with the lower efficiency based on thermodynamics, that we upgrade the system. So the system is much more advanced and much more enhanced in order to cope with the lower efficiency in that case. While using an A1 or A2L refrigerant, very similar, very simplified system. But even here, and this is something I will show you in the end, there are ways also to improve the efficiency further of F-gas systems. So this is just an example. It's like a theoretical based information based of RefProp 10. It's mentioned there. So just like some to compare some legacy refrigerants with new A2L refrigerants such as R-454C, and we definitely see there's a way lower GWP compared to other refrigerants or solutions which were used very much in the past and which is still. Yeah? Okay. Sorry. So you can hear me again. Again, this is theoretical based on RefProp database. This is the upper left corner. You see that it's for low temperature applications. See two or three refrigerants, and what we see here is that the efficiency is very similar, but there's a little capacity loss when using R-454C. But even here, we have a solution to cope with that. So in order to deal with possible charge limitations and safety there are ways of improving the capacity as well as the efficiency of A2L systems. So this is another example for medium temperature. I just added those data just to show you, because I think the presentations will be available afterwards. So I will not go into any depth here. It's just for you to see the thermodynamics of 454C compared to the other refrigerants, mainly used in each application: low temp, medium temp, and high temp. So starting with that, we've made, or I've, let's say, collected few case studies, and which I would like to show you. And in each case study, 454C is used, and they're all in different kind of industry sectors, kind of different applications being used. Starting with that, there's the one market case study used 454C. It's supermarket sales are of roughly 700 square meter, and it's been used for medium temperature as well as low temperature here in that case. So one refrigerant as well, dealing with both application ranges, and we got a pretty good and pretty positive feedback from the customer as well as the end user, and this is something they would like to consider further. And as well here, the easy fight system, so the very simplified system, this is something which was very much shout out, and they were interested in considering those further. We have another case study from Frigo for ice making machines. Again, different application, much smaller system. So they're having roughly 4,000 kilogram making ice per day, and very important, especially for ice, because if you cool it too fast or too slow, the ice gets bad shape, kind of it's getting white, and this is what they would like to avoid. So they've made many tests using 454C, coming from 404A in that case, comparing those, and building all of that now with 454C, also for larger machines like this. There's third case study here in that case, using condensing units in this case. So here we used Bitzer Ecolite condensing machines. It's a freezer, so low temp again, using 11 kilogram per system. This was done in obviously for safety reasons, but also to make sure we have a certain redundancy of the system. So in order one system may fail, there's another system picking up and keeps the whole system running, and making sure the client, the end user, is always on the safe side. And this is another one. I think this is a very interesting case study. First one we have in this area, I have to say, there was an old system, an industry system, a flooded system, flooded evaporation. I remember in the beginning when I worked in refrigeration, always the rumors, flooded systems using glide refrigerants, very tough. Yes, but there are ways to cope with it. So if you have questions, if you're interested, please join us, and we're happy to discuss this with you further. So I think I have not much time left, so I will move on. So conclusion, the regulatory landscape, there are incentives, there are regulations in place, such as the F-gas regulation. They decrease the GWP limits as well, banning some refrigerants. So this is in place, especially in Europe. There are solutions available which can be used with low GWP, and as well as we're on the other side, we're safe. There are other regulations taking care of the safety, such as the EN 378, for example, and the system complexity. One of the big advantages of A2L refrigerants is the less complexity of each system used. But there are ways of improving it, making the system more efficient, but also a little more complex. But what you see here is, as an example, there are not too many details here on purpose, which cannot be shared like this. So if you're interested in looking into this, I think the numbers are very impressive. CO2, COP improvement, comparing same refrigerant, some different measures on the system, regulation, and component-wise, we can increase the efficiency of up to 36%. And the cooling capacity, which is another thing, because using 454C, you will have less cooling capacity compared to 449A, for example. But even there's a way of improving it by up to 42%. So we cannot just cope with it, we can also increase it by far, which is very important considering safety and charge limitations. So with that, I say thank you. I think I'm already a little bit over time, so sorry for that. And